1. Avian flu costs, dairy industry, over $737,000. Study reveals heavy economic impact. 2. Uncovering hidden dangers. How flies and milk snatching spread avian flu in dairy cattle. 3. Breakthrough universal influenza vaccine for cattle to combat H5N1 outbreaks. Purdue research. 1. Avian flu costs, dairy industry, over $737,000. Study reveals heavy economic impact. *** warning. Avian flu's hidden toll on dairy farms will leave you stunned. ***. Imagine a single outbreak of avian flu wiping out nearly $750,000 from a dairy farm's coffers. Sounds alarming? That's precisely what happened in an Ohio dairy farm, as revealed in a recent study published in Nature Communications. https://www.nature.com/articles/s/41467-025-61553-Z. But here's where it gets even more concerning. The highly pathogenic avian influenza, HPAI, H5N1 strain, which has been wreaking havoc since 2022, claiming the lives of approximately 175 million birds, has now set its sights on mammals, including dairy cattle. As of the latest reports, https://www.cidrap.um and
edu/avian-influenza-bird-flu/quick-flu-avian-flu-arizona-vaccine-price-cut.
A staggering 1,074 herds across 17 states have fallen victim to this outbreak. ***, the Ohio farm outbreak. A closer look. ***. Cornell University researchers delved into the aftermath of the outbreak on a farm housing 3,876 dairy cows, which occurred in spring 2024 following the introduction of 42 seemingly healthy lactating cows from a Texas farm. By analyzing data from before, during, and after the outbreak, March 8 to June 7, they uncovered some startling statistics. Infection rate ***, out of 3,433 lactating cows, 88.6% of the total herd, 777 cows, 20%, contracted the flu, exhibiting severe mastitis, decreased milk production, loss of appetite, apathy, and reduced rumination time. ***, mortality, and culling ***, a staggering 53 of the 777 infected cows, 6.8%, succumbed to the disease, or were euthanized within an average of 13.6 days post-diagnosis. Another 245 cows, 31.6%, were culled within 20.6 days, highlighting the swift and devastating impact of HPAI. Increased risk ***, infected cows were at a sixfold higher risk of death ***, relative risk, 6.0, and more than triple the risk of being removed from the herd ***, 3.6, compared to their uninfected counterparts. ***, key takeaways and controversy ***, seroprevalence ***, an astonishing 89.4% of the herd showed the presence of avian flu antibodies, with 76.1% of seropositive cows being infected. Risk factors cows between 100 to 200 days into milk production, and those who had given birth more than once were more susceptible to infection. Economic toll the estimated loss per cow, due to decreased milk production, approximately 900 kilograms, or 1,984 pounds, over 60 days, and cow loss was about $950, culminating in a total loss of $737,500 for the farm. Asterisk asterisk the way forward, biosecurity measures and vaccine development asterisk asterisk. As the dairy industry grapples with the aftermath of such outbreaks, the emphasis on stringent biosecurity measures and the development of effective vaccines becomes more pressing than ever. Asterisk asterisk, but here's the part most people miss, asterisk asterisk in the rush to find solutions. Are we overlooking the long-term, potentially devastating impacts on herd dynamics and reproductive losses? Asterisk asterisk, we want to hear from you, asterisk asterisk. Do you think the current measures in place are sufficient to combat the spread of HPAI in dairy farms? Should there be more emphasis on vaccine development for dairy cattle, potentially diverting resources from other areas? Share your thoughts and opinions in the comments below. 2. Uncovering hidden dangers. How flies and milk snatching spread avian flu in dairy cattle. A shocking new discovery has emerged in the world of avian flu. House flies and a mysterious milk snatching phenomenon may be playing bigger roles in spreading H5N1 to dairy cows than previously thought. While U.S. outbreaks of this deadly virus in cattle and poultry remain rare, scientists are still racing to uncover the full picture of how it moves through farm ecosystems. Two groundbreaking findings this week have reignited debates about the hidden pathways of H5N1 transmission. But here's where it gets controversial. Researchers are now questioning whether farm pests like flies, and even the way cows nurse their calves, could be key players in spreading the virus. This week's revelations come after a 30-day period with only one poultry case and 2 dairy cow infections reported by the USDA, a stark contrast to the high levels seen in other regions. Yet, as the World Organization for Animal Health, WOAH, reported, wild bird outbreaks are surging, especially in Europe, suggesting the virus is still finding new ways to spread. In the early days of H5N1 in dairy cattle, experts blamed the movement of infected animals and contaminated equipment. But when outbreaks kept happening despite strict state restrictions and enhanced biosecurity, the search for alternative explanations began. Enter houseflies. A study by a computational biologist in New York found that a California fly sample from October 2024 matched the H5N1 strain found in cows. These insects act like tiny messengers, the researcher explained, carrying the virus across farms without infecting people or other animals, but that's another reason to beef up farm safety protocols. Meanwhile, a former paramedic turned flu expert, Mike Costin, pointed to a 2006 Japanese study showing blowflies could transfer the virus via their feet after touching infected poultry. We're not talking about flies that normally carry the virus, he noted, but contaminated ones could be a major, overlooked factor in HPAI spread. He also highlighted recent research suggesting blowflies at a Japanese crane colony might pick up the virus from dead birds or feces, adding fuel to the debate over how the virus moves between farms. Now, a different twist. A Chinese team discovered that H5N1 might initially infect cow mammary glands through a process called milk snatching. In experiments, they found that when the virus enters a cow's nose, it replicates in the mouth and lungs, but when it reaches the teat, it stays localized in the mammary gland. This suggests that the way cows nurse their calves, or even calves nursing cows, could be the first step in infection. Researchers also found that bovine oral tissues have high levels of sialic acid receptors, which might help the virus stick to feed and water sources, allowing it to replicate efficiently. To combat this, scientists tested 2 vaccines in lactating cows, an inactivated H5 vaccine and a DNA-based hemagglutinin vaccine. Both provided complete protection against H5N1, even after high-dose challenges through the mammary gland. But unless we fully understand how the virus spreads in the wild and between farms, containing these outbreaks will remain a challenge. What does this mean for our approach to managing H5N1? Are we missing key players in the chain of transmission? Share your thoughts in the comments, because the story isn't over yet. 3. Breakthrough universal influenza vaccine for cattle to combat H5N1 outbreaks. Purdue research. Imagine a future where a single vaccine could safeguard our cattle against both today's deadly influenza strains and tomorrow's unknown mutations. It sounds revolutionary, and it might also spark substantial debate among experts and farmers alike. But here's where it gets even more interesting. Researchers are not just targeting avian influenza, H5N1, for dairy cows. They are also devising a plan that could protect against a range of future viral threats. In an exciting move to bolster U.S. agriculture, Purdue University recently received a $301,562 grant under the Rapid Outcomes from Agricultural Research (RAW) program through the Foundation for Food and Agriculture Research (FFAR). This funding supports projects that spring into action against sudden perils threatening the nation's food supply and agricultural operations. The primary goal of Purdue's project is to create a groundbreaking universal influenza vaccine for cattle, including protection against H5N1. On top of that, the vaccine is projected to be effective against potential mutations that may appear down the line. 1. Although reported cases of H5N1 in dairy cattle within the United States have slowed recently, sporadic discoveries still pop up. 2 Notably, on July 11, 2025, the USDA Animal and Plant Health Inspection Service (APHIS) confirmed the first detection of H5N1 in a California dairy herd since early June. 2. 3 Overall, infections have been identified in 1,075 herds across 17 states, making it clear that the virus remains a pressing concern for agricultural health and livestock owners. 2. 3. One of the key reasons for urgency, according to Miriam Martin, Ph.D., FFAR's scientific program manager, is that H5N1 poses not only an animal health scare, but also a human safety worry, especially for dairy workers who might be exposed. The detection of avian influenza in dairy cattle, with risk of infection to dairy workers, underscores the need to develop effective vaccines for non-avian species, she said. She further highlighted that the rapid funding is intended to protect animal health, farmers' livelihoods, and even consumers' wallets. 1. So, how exactly do researchers plan to achieve this? The Purdue team, led by distinguished virology Professor Suresh K. Mittal, DVM, Ph.D., is leveraging knowledge from its long-standing work with influenza A viruses and a bovine adenoviral vaccine platform. This unique platform uses a virus that can naturally infect cattle without causing severe illness. It essentially serves as a carrier for genetic material that teaches the cow's immune system to fight off influenza. According to FFAR, the vaccine is also designed to remain effective if the virus mutates. 1. The method for administering the vaccine will be tested via intranasal and intramuscular delivery, allowing scientists to compare which route yields the best immune response. Mittal explains, because this vector system is so universal, we can use it for any agent and for any host. 1. In other words, if successful, this technique might not only lead to breakthroughs for cattle influenza, but could potentially be adapted for other emerging diseases in various animal populations. And this is the part most people miss. Exploring a single technology that can handle multiple threats opens new doors in vaccine innovation. Collaborating with Mittal on this project are Purdue's Associate Professor of Food Animal Production Medicine, Rafael C. Neves, DVM, Master of Science, Ph.D., and Assistant Professor of Poultry Medicine, Ekremi Saitahmed, BVM, MS, Ph.D. Together, they form a multidisciplinary team well equipped to tackle this multifaceted challenge. Moreover, this particular effort isn't the first time FFAR has financed H5N1 research. Earlier this year, a startup mRNA, nanoparticle-based animal vaccine company from Iowa, GenVax Technologies, received a $278,163 grant to pursue a similar goal for dairy cattle. For their approach aims to develop an H5N1 vaccine and deploy diagnostic tools that distinguish between infected and vaccinated cattle, a crucial capability to guide targeted culling or quarantine measures during outbreak situations. By ensuring these tools work for both mature dairy cows and calves, GenVax is broadening the scope of disease prevention strategies. 4. Helming this work at GenVax is Hank Harris, DVM, PhD, Emeritus Professor at Iowa State University, and co-founder of the company. The team hopes to gather enough data to submit to the USDA's Center for Veterinary Biologics, which could grant them a conditional license to use the vaccine on dairy farms. 4. This development could provide yet another layer of security for the U.S. cattle industry, but it also raises questions. How will regulatory agencies keep pace with rapidly advancing technologies, and are there any risks that might surface if universal vaccines become widespread? This is the part that could stir controversy. Some people worry about the potential long-term effects or new viral strains that might evolve in response to heavy vaccination. Could it lead to resistance or make other pathogens stronger? Naturally, there are differing opinions on whether these vaccine platforms are a necessary leap forward or a high-stakes gamble. At the end of the day, scientific teams nationwide are racing to protect not only the dairy industry, but also the broader agricultural sector and public health. Now, we'd love to hear what you think. Do you believe that using cutting-edge vaccine technologies for cattle is the best way forward? Or are you concerned about the potential unknowns? Let us know your take in the comments, whether you're a farmer, a scientist, or just an intrigued onlooker reacting to these bold steps in veterinary medicine. References: 1. FFAR research aims to protect dairy cattle against H5N1. News release. Foundation for Food and Agriculture Research. June 25, 2025. Accessed July 15, 2025. 2. HPAI confirmed cases in livestock. U.S. Department of Agriculture Animal and Plant Health Inspection Service. July 9, 2025. Accessed July 15, 2025. 3. Schnering L. Quick takes. More H5N1 in dairy cattle. U.S. COVID wastewater uptick. Polio in Pakistan. Center for Infectious Disease Research and Policy, University of Minnesota. July 11, 2025. Accessed July 15, 2025. 4. FFAR grant develops H5N1 vaccine for dairy cows. News release. Foundation for Food and Agriculture Research. April 23, 2025. Accessed July 15, 2025.